It's thought that, around 13.75 billion years ago, our universe as we know it today came into being. Not long after that, the primordial light started to spread throughout the early universe. At this point, the universe itself also started to expand. However, the expansion of the universe slowed down after the initial burst, but since then, it has been growing at a steady pace thanks to the influence of dark energy. In a nutshell, the universe has been growing at an ever-increasing rate since it came into being. For hundreds of years, physicists and mathematicians have been trying to solve the mysteries of the universe. Some scientists are even thinking about what lies beyond the boundaries of our universe. Could there be something else out there, beyond our own universe? Could there be other universes out there, worlds that we can only guess at? That seems likely. Here are 5 theories about what this something could be and what evidence there is for each one. Hubble volume. It's not easy to define what we mean by outside the universe, because we first have to define the universe more precisely. A more accurate way to describe it is the observable universe, where the speed of light is a key factor. As we can only see things when the light they emit or reflect reaches us, we can never see further than the greatest distance that light can travel in the time that the universe has existed. The oldest photons we can observe are thought to have traveled 45 to 47 billion light years since the Big Bang, according to cosmologists. This means that the observable universe is about 93 billion light years across, give or take a few light years. That's about 93 billion light years of everything we've ever seen with a telescope, including all the quarks, quasars, stars, planets, nebulae, and black holes. The observable universe only contains the light that has had time to reach us. This also means that the observable universe is getting bigger all the time. However, the universe is also finite. This limited amount is also known as the Hubble volume, named after the telescope, that has provided us with the most distant views of the universe to date. We'll never be able to see beyond this limit, so it's basically the only universe with which we can ever interact. However, we know with almost total certainty that there's more out there beyond that limit. Astronomers believe that space invisible to us could also be infinite, with matter, energy, galaxies, etc., distributed pretty much exactly as in the observable universe. Once we look beyond the Hubble volume, we'll not only find more planets, but also other planets that are very similar to our Earth. If we keep going, we'll find another solar system with an Earth that's identical in every way. You could have cereal for breakfast this morning instead of eggs, or you could have skipped breakfast, or you could have got up in the morning and then robbed a bank. In fact, cosmologists believe that if you go far enough beyond the boundaries of the universe, you will find another Hubble volume that is completely identical to ours. In those other Hubble volumes, there is another version of you out there that reflects every possible action you might take. This may seem unlikely, but then again, the infinity of the universe is very hard to imagine because it's simply beyond human imagination. The theory of relativity basically says that things that are close together can't move against each other faster than the speed of light. However, there isn't a law that applies to objects that are extremely far apart when the space between them expands. In a nutshell, it's not that objects move faster than the speed of light, but that the space between them expands, causing them to fly away from each other at incredible speeds. So, ultimately, we could only reach the edge of the observable universe if we developed a transport method that would allow us to either 1. Travel faster than the speed of light, which most physicists believe is impossible, or 2. Transcend space-time by wormholes or warp propulsion, which most physicists also believe is impossible. In 2008, astronomers made an unexpected discovery. Galactic clusters were streaming in the same direction at incredible speeds, reaching over 2 million meters per hour. New observations in 2010 confirmed this phenomenon, which is known as dark flow. Scientists made the discovery by studying some of the largest structures in the cosmos, giant galaxy clusters. These clusters are made up of around 1,000 galaxies in very hot gas that emits X-rays. By looking at how X-rays interact with cosmic microwave radiation, or CMB, which was left over from the Big Bang, scientists can study the motion of clusters of galaxies. The X-rays bounce photons into the cosmic microwave background, which changes the temperature in a process called the Sunyaev-Zeldovich kinetic effect. This effect hadn't been seen before in clusters of galaxies, but it was first spotted by a research team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center. They looked at about 700 clusters that were up to 6 billion light-years away, halfway across the universe. They compared these clusters with a map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe, WWMAP satellite. The movement of the clusters challenges all expectations about the distribution of mass in the universe after the Big Bang. One possible cause is massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of the suction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our point of view. As for the structures themselves, they could literally be anything, from accumulations of matter and energy on almost unimaginable scales to bizarre fault lines that conduct gravitational forces from other universes. Infinity bubbles. It's worth noting that talking about things outside the Hubble volume may be a bit misleading. After all, it's still part of the same universe, just a part we can't see. The same physical laws and constants apply. Another version of the story is that the expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding along with the rest of space, forming its own universe with its own laws and physical constants. In this scenario, space is infinite, and each bubble is also infinite because a single infinity can contain an infinite number of infinities. Even if you could somehow break through the boundary of one bubble, the space between the bubbles would still expand, so you would never reach the next bubble, no matter how fast you move. Black holes. Lee Smolin, a physicist, came up with a theory called the theory of fertile universes. It says that every black hole in our universe causes the creation of a new universe. Each universe will have slightly different physical laws to the last. This means that, according to Smolin, there's a kind of natural selection for universes. The laws and physical conditions that lead to the formation of black holes also lead to the formation of other universes, while universes that don't form black holes become extinct. Smolin and others have since shown that the theory is incorrect. There could be an infinite number of parallel universes. There are lots of different ideas about parallel universes, but the one that seems to make the most sense today is based on the ideas of string theory. This is all about membranes that oscillate in different directions. We won't go into too much detail about string or membrane theory here, but the basic idea is that the rippling membranes beyond the worlds in the 11th dimension are completely different universes. When the waves collide, a new universe is born. The effects of wave motion help us to understand how matter is distributed in our universe. One of the strangest things about this theory is the idea that all the gravity we experience in our universe actually comes from another universe in another dimension. This could explain why gravity here seems so weak compared to the other fundamental forces. What are your thoughts on this? Could there be other unknown worlds outside our universe? Is infinity a real thing? And if so, how big is it? Parallel universes, warping matter, string theory, membranes, and black holes. Do you think it's all just nonsense? Or is there really something to it? We'd love to hear your thoughts in the comments.